Okay, so here's question 12 from practice set 1, paper 2. We're asked to find the equation of the normal to a curve, which means we need the gradient of the curve. So it's a differentiation question, and this is a quotient. So you need to recall the quotient rule and set up your windows. So I'm going to have, this is my u, and this is my v, and I'm going to differentiate that and just plug it in there. I'm going to do that. I suggest you pause the video and do the same. Okay, I did v du by dx, so 3 times 20 is 60, and u dv by dx, so I did 6 times that to give me this, times e to the 2x, and then that's divided by u squared. And we're asked about the point where the x-coordinate equals 0. So the gradient is what you get from this when x is equal to 0, which looks horrible, but actually isn't too bad at all. So again, pause the video and either using a calculator or manually see what that becomes when x is 0. Okay, so when x is 0, that term's going to disappear. This term's going to disappear. This is going to be minus 36. So that's 36 times that. Well, when x is 0, that's e to the power of 0, which is 1. So the top is going to become plus 36. And the bottom, well, that's 1. E to the power of 0 is 1. So 3 times 1 squared is over 9. So that's 4. Your calculator would have told you that anyway. This is an finding the equation of the normal. So that's the gradient of the curve itself. That's the gradient of the tangent to the curve. So the gradient of the normal is going to be minus 1/4. And the other thing we need to work out an equation of a straight line is a point. And we know the point is when x is 0, so what I now need to do is to substitute 0 into the original function. So again, pause the video and see what. Okay, again, calculator would have told you, but when x is 0, that becomes 0, so you've got minus 6, and you've got 3 lots of 1, so minus 6 over 3, which is minus 2. So from here it's just the standard. We know the gradient's minus 1/4, so the equation is that, and then we just make x equal to 0 and y equal to minus 2 to calculate that. So y equals minus 1/4 x minus 2. We're told to give it in the form with whole numbers, so I'm going to multiply everything by 4 and then shovel everything onto the left hand side. So I've got x plus 4y plus 8 equals 0. Quick check of the answer booklet. I'm hoping that's correct. And it is correct. There we go. So that's that, question 12. Okay, and here is question 14. We're asked to use proof by contradiction to prove that the hypotenuse is less than the sum of the other two sides. So we start by assuming the opposite. Assume the hypotenuse is greater than the length of the other two sides. We're hoping to prove this can't be true. So let's set up some definitions. I decided to just draw a little picture to show that I'm calling the other two sides A and B and the hypotenuse H, and we're assuming that H is greater than A plus B. So what I've done firstly is square both sides of that inequality, which I'm perfectly able to do. And if I grid that out, it becomes that. So this is our assumption, but we're hoping to be able to prove it's not true. And at this point, we just throw in Pythagoras. That's a known fact. We can do that. Pythagoras tells us that this squared is equal to that squared plus that squared. So I'm going to replace this with a squared plus b squared. Can you see a problem with that statement? Well, yes. This can't be bigger than this because this side's got this extra term. Unless this was negative, but of course A and B are the length of a triangle, so this can't be true, sorry. and I apologise for my handwriting, it is late, this which can't be true because A and B are both positive, and so therefore our assumption was incorrect. The hypotenuse must be less than the sum of the other two sides, as required.